So in this video, let's practice solving a few horizontally launched projectiles. So remember in another video when we started introducing projectiles, we talked about how when you think of a projectile problem, you want to think of it in terms of the x dimension behavior and the y dimension. So if you shoot something and it falls, right, it follows a parabolic path. So you can think of it as something that's traveling forward in the x dimension at a constant speed, but also something that's falling like it was released from rest in the y dimension. And so we have two equations that apply in the y dimension. So basically this one is that position as a function of time equation, the big quadratic one, but narrowed down to where a is now g, which is the acceleration due to gravity on Earth. And then you can rearrange this formula to get this one that tells you the time that it'll take to fall, right? And so remember, this is only good for horizontally launched projectiles. And then in the x dimension, it's just velocity equals distance over time because there's no acceleration in the x dimension. Okay, so let's look at an example problem. You can pause it to read this. Okay, so the first thing I do is draw it out. So in this problem, right, it's always going to make your life a whole bunch easier if you just draw it out. So you've got an airplane, right, and it's going some velocity, and we don't know the velocity, but I know that it's flying at 500 meters, and then when it drops something, it lands 400 meters away. And so we want to figure out how fast that plane was going, right? So it's going to let it go, and it's going to follow a parabolic path and hit the ground like that. Okay, so first thing you got to do, first step always projectile problems is find the time. Okay, so we know the height, right? And we know g's a constant, so we can solve for the time. So 2 times the height over g, and that gives you 2 times 500 by 10, and that comes out to 10 because 2 times 500 is 1,000, divided by 10 is 100, square root of 100 is 10, so 10 seconds. That's how long it's going to take to hit the ground. Okay, so now we can come over here and say, I want to know this velocity. It's just the distance in the x dimension divided by the time. So the velocity of the plane is going to be the distance in the x dimension, which was 400, divided by what I just got as the time. So my velocity is going to be 40 meters per second. Okay, so here's the next problem. Pause it if you want to read it. So in this case, we know the velocity, same type of problem. We know the velocity, but now we want to figure out the range that it's going to travel. Okay, so in this case, it's somebody shooting a gun, right? So here's the bullet, and it tells us we have a velocity of 415 meters per second. And we don't know the range, but we do know that it's 1.8 meters high. I know that's not to scale, but whatever. So we know the height, so we can get the time, right? First step, always get the time. So I get 0.6 seconds for my time, right? So 2 times 1.8 was the height, divided by, I'm using 10 for g instead of 9.8, right? Square root of that gives me 0.6 seconds. So now I have the time. I want to know the distance. I know the velocity, right? This is my only equation in the x dimension, right? Because there's nothing accelerating. So I have to rearrange this. So velocity is displacement over time, right? If I want to solve for the x position, the displacement, I should say, I got to multiply time over, right? So delta x is equal v delta t. Right, so now I can solve. So my velocity is 415, my time is 0.6, so that gives me 249 meters that it's going to travel. Okay, third problem. You can pause it again if you want to look at it. So basically, this one now, you know the distance it travels and you know the velocity, but we want to figure out the height. So this one involves a little bit of working backwards. Okay, so it's got somebody standing on top of a cliff and they throw something, right? And it says they throw it at 3 meters per second, and it lands 4.5 meters away. And we're trying to figure out how high that little cliff is. Okay, so notice we don't know the height, so we can't solve for the time. Normally what we were doing was we'd get the time first from this free fall equation. Can't do it that way. So how do we approach this? Well, you got to look at what you have. So I know the x displacement and I know the velocity, but I don't know the time or the height. So when you look at these equations, what do I know? Well, look, I know two of these three right here. So I can solve by plugging in the displacement in the x dimension and the velocity, and I can get the time. So if velocity is delta x over delta t, if I want to solve for delta t, I can switch these two, right? Because it's the same as multiplying over and then dividing, right? So the time is going to be equal to delta x over velocity. So that's going to be equal to 4.5 over 3, and that comes out to 1.5 seconds. That's ugly. Right? Okay, so now we know the time. Now we're working backwards. So before, what we've normally done is taken here and then go to x. Now we used x, so we're going to go to y. Right? So if I want to get the height, there's only two variables in the y dimension, right? So there's delta y and delta t. So let's solve this equation for delta y, right? These are the same thing. So delta y is 1/2 gt squared. So that's 1/2 times 10 times 1.5 squared. So when you do that, that comes out to 11.25 meters. So the cliff is 11.25 meters high. Okay? So all horizontally launched problems are like this, right? So this only works when you shoot something horizontally where there's no angle. Okay? So these equations apply. If you shoot something at an angle like this, that's going to be a different type of solution. There's another video I'm going to do that's like that. So it's the same process, same kind of stuff, but you have to work with vector components now because this is at an angle. Okay, so remember the steps. Find the time first, always the first step. Okay, once you know the time, you can come to the x dimension or the y dimension in this last case and solve for what you need.